The materials required to manage extreme acidity and metal toxicity are often already found at the mill, providing a biological alternative to synthetic inputs. Welcome to AGS, Agriculture Global Solutions. We translate scientific research into practical strategies for agricultural professionals. Field advisors across the industry frequently encounter the same operational hurdle: planting blocks stalled by highly weathered, acidic, and profoundly degraded soil. This animation illustrates the invisible chemical threat. High acidity allows metals like aluminum and iron to dominate the soil profile. They actively block nutrient pathways, often preventing the establishment of legume cover crops or palm seedlings. To test potential solutions, researchers utilized this vast post-nickel mining site in Indonesia. The soil here has been stripped and left with very high levels of exchangeable iron and aluminum. If a biological intervention improves this destroyed earth, it becomes a viable candidate for standard commercial plantations. Research shows that pairing two specific materials significantly rehabilitates this extreme degradation, providing a clear path forward for soil recovery. The first material in this partnership is oil palm empty fruit bunch, or OPEFB compost. In highly degraded areas, OPEFB performs a chemical function that extends beyond standard organic matter enrichment. As shown in this diagram of the compost breaking down, the decomposition process generates specific organic acids that flow into the surrounding soil. These acids quickly restructure into chelating compounds, specialized molecules shaped remarkably like tiny claws. Those claws seek out the free-floating aluminum and iron currently limiting plant growth. They lock on to the toxic metals and neutralize them. Neutralizing these toxic metals leads to a direct, measurable increase in the soil's overall cation exchange capacity, or CEC. High CEC allows the soil to better retain valuable base nutrients like calcium, magnesium, and potassium, preventing them from leaching away during heavy rainfall. By acting as a chemical repair agent, the compost reduces toxic threats and readies the environment for the next phase of recovery. While chemistry is vital, plants also require a physical means to access those newly available nutrients. This introduces the second partner, mycorrhizal fascicular arbuscular, or MVA fungi. As you can see in this macro footage, MVA spores introduced into the soil attach to and colonize the roots of the legume cover crop. The fungus acts as a living underground extension cord, growing microscopic threads called hyphae that radiate deep into the soil. This comparison shows the physical advantage. A standard plant root is often too thick to enter the smallest soil pores. However, the fine MVA hyphae easily weave through these microscopic spaces. Deep inside those spaces, the fungus extracts locked up phosphorus and water, channeling them directly back to the plant. In exchange for this continuous supply, the plant provides the fungal network with carbohydrates to fuel its continued growth. Together, OPEFB compost repairs the chemical profile, while the MVA fungi physically equip the plant to completely thrive within it. This research suggests that OPEFB is a strategic asset for land rehabilitation. For the most severely challenged planting blocks, biological site preparation should be considered a standard operational phase. The protocol tested in this Indonesia study combined MVA fungi with mature OPEFB compost applied at a rate of 10 tons per hectare for extreme conditions. Executing this protocol creates the favorable environment required for a legume cover crop to successfully take hold. Establishing night cover crop immediately helps stabilize topsoil and kickstarts the biological nutrient cycle. By utilizing this biological partnership, operations can improve outcomes in underperforming terrain while managing their long-term reliance on heavy synthetic inputs. The OPEFB and MVA protocol represents a research-backed strategy for converting barren land into a productive plantation asset. Do not forget to subscribe and follow us. Thanks for listening.